Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And I am Jeetendra Dixit. Here is my profile. So, I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. I teach mathematics and we were doing complex numbers in this session. So I'll continue complex numbers and today I'll start complex geometry. And tomorrow also I'll continue complex geometry. So this is the first session of complex geometry. So anyone who has not followed previous sessions doesn't matter because this is the first session of geometry. But you should have basic knowledge of complex numbers like modulus, argument. That will be required, okay, while doing the complex geometry. And obviously, yes, circles, geometrical. Yeah. So properties of circle, straight lines, locus you should know, okay, to understand this geometry. So we'll continue the session, but before we start, let's discuss about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform, and once you get the subscription for Plus, there are two types of subscription. One is Plus subscription, and other is Iconic subscription. So I'll give you the details of both. Plus subscription, when you take, then you get access to daily live classes of all the educators who are teaching on Plus. So India's top educators are teaching on Unacademy's platform. You can follow their courses and you can follow ongoing courses as well as every week there are a lot of new courses starting, so you can watch new courses also. You can follow new courses. And there's no restriction. You can watch videos of any educator, live sessions of any educator who is teaching there. So it's up to you. This is unlimited access you are getting on Plus platform when you have this Plus subscription. All the tests and quizzes will also be accessible to you. So, and about this course, these courses are well structured taken by educators of Unacademy. So you can see the schedule of all the upcoming sessions in well advance with time, date, and topic name. All right. So you can plan your schedule accordingly. And live sessions are very interactive. You can ask your doubts during the live session. You can participate in poll. You can send your doubts. There will be dedicated doubt sessions as well, okay, apart from these classes. Now let me tell you about the subscription charges. So yeah, so for 12 months you'll have to pay 38,500, and for 24 months you'll have to pay 56,000. Okay, 56,000. But you'll get 10% discount if you use my code JEET1. Use this code JEET1 and get instant 10% discount. So this 12 month subscription will become of 34,650, and 24 months will be of 50,400. Close. All right. Okay. Now let me tell you about Iconic subscription. So as you know, Iconic subscription, you get all the benefits of Plus in Iconic subscription, and apart from that, you get a personal coach as well, who will guide you throughout your preparation for all top exams like IIT-JEE Advanced, Main, and BITS. Okay, your test analysis will be done in a personalized manner, and feedback will be given. Personalized feedback will be given to you to improve your time management and exam approach. And your study planner will also be customized. Okay, and bi-weekly reviews will be given to improve your performance. All right, progress. So this is Iconic subscription in which you are getting personal attention by an expert, okay, and personal help in your test preparation, study planning, okay, time management or exam approach. An iconic subscription you can buy for 12 months and 24 months. 12 months price is 56,000, and on that you'll get 10% discount. You'll have to pay 50,400. Okay, use this code Jeet1 and get instant 10% discount. And for 24 months you'll have to pay 86,000 again. Use the same code and you'll have to pay 77,400. All right. You can download this Unacademy's learning app from Play Store, and after downloading it, you can even without getting the subscription, you can start your preparation. You can attend special classes. Okay, so every day a lot of educators are taking special classes on Unacademy, so you can take you can watch those special classes, you can attend those classes live. All right, and during those classes also you can ask your doubt, you can participate in polls. So these classes are exactly the same, like same platform you get on Plus also, which you are getting in a special classes. Okay, just go and attend these special classes and you'll come to know about the platform, about the I mean how interactive it is. You'll get to know. And as long as you're not taking the subscription, then you can learn a lot of topics through special classes also. All right, I also take a special class at 8:30 the evening, in which I take doubts. Okay, so you can come and join those special classes. All right, now let's begin the session. Mm, so this was complex geometry. Okay, so let's begin it. Okay, so I'll tell you the basics first of all. The very first basic is this. What is this mod of z1 minus z2? All right. So mod of z1 minus z2 is basically if this point is z1 and this point is z2, then distance between z1 and z2. Okay. So in Argand plane, z1 and z2 are 2 points, two complex numbers, and distance between z1 and z2. All right. So this distance is basically mod of z1 minus z2. You know mod of z is distance of z from origin, right? So if you put z2 is equal to 0, that means it becomes mod of z1, and that represents distance of z1 from origin. Similarly, if you talk about argument of z1 minus z2, then what is this argument of z1 minus z2? So for that you need to make a real axis, because this argument is angle. So angle is, see, this is z1 and this is z2. Okay, so z1 minus z2. Okay, let's take this z2 and this z1. So z1 minus z2 is basically this vector. Okay, you can take this as a vector. When you take mod, then it gives you the length, and when you take argument of z1 minus z2, so direction is towards z1 minus z2. All right, like vectors, position vectors. and it represents the angle, okay, angle made by this z1 minus z2 vector with x-axis. Okay, so this angle is argument of z1 minus z2. Okay, so these two are very important points. First of all, before we begin the session, you should understand this. Okay, so z1 minus z2 mod is distance between z1 and z2, where z1 and z2 are two complex numbers on argand plane, and argument of z1 minus z2 is angle made by this vector joining z2 to z1. It will be towards z1. Okay, so now I'll tell you the first curve. So it is given that z is a variable complex number, and z1 is a fixed complex number, and a is a positive constant, then z minus z1. Okay. Then equation z minus z1 is equal to k mod of z, sorry, not k, let me write it again. And let's write like this, and z satisfies z minus z1 mod is equal to a. Okay, so now see, then locus of z is, then locus of z. Okay, so this is pretty simple. You can easily guess this, you can figure it out easily. So z1 is a fixed complex number and z is a variable complex number, and as I told you, z minus z1 mod will represent distance between z and z1, and this distance is given constant a. All right, so that means the locus of z will be a circle, all right, of radius a. So it's a circle of radius a and whose center is it's z1. All right, so locus of z is a circle of radius a whose center is at z1. All right, so this is the first very basic equation which most probably you all know. Okay, so this is very important as well. As we write equation, then z lies always on the circumference of the curve. But if I make this in equation, right, like this, if I write second part of the same curve, this is, let's take this as first part, right? Then second part is this, z minus z1 mod is less than a, all right, less than or equal to or less than. Then where will be this z? Now, whenever it's an inequality, then z will lie on one side of the region represented by the equality. All right. So if you replace this inequality by equal to sign, then you'll get a curve, and that curve is a circle, right? And this inequation represents a region, and that region is either inside of the circle or outside. So let's figure it out. Z1 is center and distance of Z from Z1 is less than A. Okay, so if it is A, then Z will be on the circle. If it is less than A, that means Z lies inside the circle. Okay, so this inequation represents interior of the circle. Okay, interior. And if I reverse the inequality, if I write Z minus Z1 mod is more than A, then obviously that will be exterior of the circle. Now distance of Z from Z1 is more than A. Okay, so that means it is outside the circle. So outside everything. Okay, this whole plane outside this circle, all the points will satisfy this inequation. So I hope you have got it, because as I told you, this is a very, very important equation and an equation, this curve. So let's do some problems based on this. Okay, so I'm giving you first part. Let's try this. See how to find these values. So z lies on a circle. It's obvious, right? We have just learned it. So z is lying on the circumference of a circle. Then we need to find the minimum and maximum values of mod of something, right? In which it's a distance of z from some number, some other complex number, all right? So let's try this. See what is written here. So if I make a circle, I'll make only one diagram, and through this diagram, we'll try to answer all the questions. So center, if you rewrite this, then it is z minus. If you take minus sign common, it is 3 minus 4 iota. That means center is 3 comma minus 4. So center is 3 comma minus 4, like this, yeah. And radius of the circle is 1. So z lies on this circle. Okay, this is 3 comma minus 4 center. So z lies on this circle. Then we need to find first of all mod of z. So maximum and minimum, that means you need to find the distance of the circle from origin, minimum and maximum distance. So whenever you need to find a distance of a circle from any point which is outside the circle, then join this point from the center of the circle. Then this distance is minimum, all right? And if you extend this further, then if I write point P, suppose this point is P and this point is A and this point is B and O is center, then PA is minimum distance of P from circle and maximum distance of P from circle is PB, all right? So use this. So that means mod of Z is distance of Z from origin. So from origin, you need to join, we just join this origin from the center of the circle, all right, and extend it. So if this point is O and if this point is A and this point is B, then mod of Z minimum is equal to OA, right? And that is basically, let's take this point C, center of the circle, okay? That is OC minus radius, right? So OC is 5, under root of 3 square plus 4 square, and minus radius is 1, right? So radius is 1, so it is going to be 4. And maximum, mod of Z maximum is going to be OB, that is OC plus R, right? So it is, that means it is 5 plus 1, 6, all right, 6. Have you got it? Subhashri, hello. We just started at 3 o'clock, 3 p.m. This is the first question I'm doing. I've just discussed equation of circle first. Equation of circle, and after that we are doing this first question. Oh, Subhashri. So, do you know how to write the equation of circle? This equation, z minus z1 is equal to a. This represents a circle with center z1 and radius a, okay? Locus of z. So we are doing that, okay? So z satisfies this curve, and we need to find, next question is, we need to find the maximum and minimum value of mod of z minus 1, okay? So mod of z minus 1. So this point is say 1 comma 0. So now you need to find the maximum and minimum value of maximum and minimum distance of this circle from 1 comma 0, because z lies on the circle. So now you need to join this point, okay? This point with the center like this, okay? So now say this point is P, and this point is say A1, and this point is B1. Then z minus 1 mod minimum. What is this minimum value? Now this minimum value is distance PA1, right? This is the minimum value. This is minimum value. So PA1. And how to find PA1? Find the distance of 1 comma 0 from center. That means PC minus radius. So if you find PC, then it is going to be under root of 3 minus 1 the whole square plus 4 square. Okay, so it is going to be root 20. Root 20 is 2 root 5, all right? So it is 2 root 5 minus radius. Radius is 1, okay? And maximum value will be PB1. So that means PC plus R, and that is going to be 2 root 5 plus 1, okay? So in a similar way, we can find this maximum and minimum of this. In this case, you need to find distance of z from 1 plus I. So would you like to try? Subhashri, would you like to try this? Maximum and minimum of mod of z minus 1 plus I. Try this third sum. Hello, Vamsi. You also try this third part. Root 32. All right. Let me check. So you need to find the distance of z. All right. So you need to find the distance of z from 1 plus I. So 1 plus I is 1 plus I is somewhere here, 1 comma 1, right? So you just join this with the center. This one. So this point is P, this point is A, and this point is say B, all right? So first let's find PC. So PC is equal to under root of 3 minus 1 the whole square, and it was minus 4 and minus 1, so it will become 5 square, right? 25. 25 plus 4 is under root of 29, right? So it is under root of 29 basically. So PC is under root of 29, but we need distance from circle because Z lies on this. Z is lying on this circle, right? So minimum distance of Z from P will be PA. Z minus 1 plus I minimum is equal to PC minus radius, okay? PA. This is PA, right? So it is under root of 29 minus under root of 29 minus 1. So that is the answer, okay? And maximum will be under root of 29 plus 1. Yeah, you got it? So in this way. Now let me give you another example. Now this one is a very good question. Z1 satisfies Z1 minus 3 minus 4 iota mod is equal to 12, and Z2 satisfies mod of Z2 minus 1 is equal to 1. Then find minimum and maximum value of mod of Z1 minus Z2. Try this one. So there are a lot of questions they ask based on this equation of circle, okay? So I'll give you all types of questions today. Meanwhile, I'll make the diagram. You keep trying. I'm just making the diagram. You try it, you try it. You try it, I'm just making the diagram, okay? Oh, it's a very big circle. हाँ देखो ऐसा है, Z1 lies on this circle, okay? Z1 इस सर्कल पे लाई कर रहा है, बड़े वाले सर्कल पे, वो सेंटर इज 3,4 and radius 12. ये जो green color से circle, we have made this circle green, with green color, right? And this Z2 lies on the another circle, this circle, okay? Z2 lies on this circle, Z2, and this is Z1. Z2's center of the circle is 1,0 and radius is 1. So you need to find, basically you need to find the distance between these two circles, right? Because Z1 is moving on this circle, inner circle, right? Z1 is on outer circle and Z2 is on inner circle. And how to find the distance between these two circles, minimum and maximum? Join their centers. So along this line, line joining their centers, you'll get the minimum and maximum along their line joining centers. So if I join their centers, see this line. If I join their centers, then this is going to be the minimum distance. This is going to be the minimum distance when Z2 is here and Z1 is here, right? Right, got it? And maximum will be, let me name these points. So say this point is A, this point is B, this point is C, and this point is D, all right? So Z1 minus Z2 minimum is basically AC, right? And Z1 minus Z2 maximum is what? Is AD, right? Hi Raghav. Yeah. Okay. So AC, how to find AC? First of all, we need to find this distance between centers. So C1, C2, distance between centers is going to be under root of 2 square plus 4 square. So that is going to be root 20. That means 2 root 5. All right, 2 root 5. So if I need to find the distance AC, then it is radius 12. That means this distance center to C. This is 12, right? Radius 12 minus C1 minus C2 minus this radius R1, okay, which is 1. Radius of this R1 is 1 and radius R2 is 12. Okay, so AC can be written as C2C, C2 is this center, C2C minus C1 C2 minus radius R1. Okay, so overall it is going to be 12 minus 2 root 5. This is distance between centers minus first radius. So yes, it is 11 minus 2 root 5. Somebody has given this answer. Yeah, 1C. Nice. Now how to find the maximum? AD. So AD is going to be what? This radius. Now this is 12. This distance is 12 radius. Okay. So 12. So AD. This is maximum distance, right? Let me mark it. This is the maximum distance. This is the maximum distance with yellow color, right? When Z1 is at D and Z2 is at A. So that distance will be maximum. I've just covered, Raghav, I just covered circle, equation of circle. That's it. The first curve. And based on that, I am doing some, I've taken three examples. This is the second example I have taken on circles. Okay, so this AD is going to be distance between centers plus R1 plus R2, C1, C2 plus R1 plus R2. All right, so this is going to be 2 root 5 plus 1 plus another circle is 12. So it is going to be 13 plus 2 root 5. All right, so that is the maximum value, maximum distance. So I hope it is clear. All right. Yeah, it's okay. All right, no problem. You can watch these complex geometry lectures later also, okay? Okay, so our next question is, I'll give you one more, okay? So the next is, if Z satisfies Z minus 5 iota mod is equal to, say, say 4, okay, 4. Then find, okay, let me change some value. Um, then find the maximum and minimum argument of Z, all right? So that is the sum. Maximum and minimum argument of Z. See how to do it. Would you like to try it? I'll make the diagram first of all. Very simple question. Geometrically we can do it. No need to do any other calculation. You just need to understand the diagram. So Z lies on a circle whose center is at 5 iota. So 5 iota is center. And radius of this circle is 4 units, right? As you can see, is 4 units. So just make a circle of 4 radius. So radius of this circle is 4 units. So it will meet the y-axis at iota and 9 iota, right? Iota and 9 iota. This point is iota and this point is 9 iota. Although these points are not required at all. So as you can see, which complex number will have the least argument? If I make a tangent, see, this is real axis, this is origin, and yeah, principal value. Okay, principal, we need the minimum value of argument, means minimum principal value of the argument. Okay, so we are talking about principal value. Principal value lies between minus pi and pi. Okay, so now you can see, if Z is in this direction, suppose Z is here, then this is the argument of Z, this angle. If you increase this angle, then argument will increase, right? If Z is here, then argument will become more, right? And for this, argument is 90 degree. Similarly, argument is keep increasing like this, right? As you can see, argument is increasing. So which complex number here will have the least argument? I mean, whose inclination will be the least? So if I draw a tangent line, which will touch this circle at some point, then this will be the complex number. As you can see, this will be the complex number with least argument. Yeah. So when Z is moving on this circle, so when Z comes at this point, it will have its least argument. Okay. For any other point, if you're taking Z here, then its argument will be slightly higher. You can see that, right? If you take Z at any other point, then its argument will be slightly higher. So this is the only position of Z where argument will be the least. So you need to find this angle, all right? Let's say this angle is theta. Now we need to find this angle, so you can do it geometrically. If you join this center to this tangent, because this line is tangent, right? So this is O, this point is say A, and this point is say C. Then this at point A, this angle is 90 degree. So you can see this is a right angle triangle. OCA is a right angle triangle. This is a right angle triangle. So if I'm taking this angle theta, argument of z theta, then this angle will be 90 minus theta, and angle OCA will be theta. So this angle will be theta. And this OC is given 5, right? This distance is 5 because C is 5 iota. And radius is given 4, right? So you can write this sine theta, you can write easily, right? Sine theta will be 4 by 5. So you can write theta in terms of, not sine theta, I'm sorry, cos theta will be. Cos theta will be 4 by 5. So you can write the answer in terms of sine theta, sine inverse or cos inverse or tan inverse, whatever you want to write. So cos theta is this. If you want to write tan theta in terms of tan, suppose options, in option it is tan inverse of something, then you can write tan theta also. So tan theta will be 3 by 4, okay? 3 by 4. So theta is going to be tan inverse of 3 by 4. Tan inverse of 3 by 4. So this is the least argument of minimum value of argument of z minimum is tan inverse of 3 by 4. And where will this angle be maximum? See, so if you keep increasing, if you z is going like this, going like this, going like this, and somewhere here, again you need to make a tangent. If you make a tangent line here from origin, okay, then this complex number for this position of z, it will have its least argument. Okay. So as you can see, this, if using symmetry, you can say, because the circle is symmetric about y-axis. So if this angle is theta, then this angle will also be theta, right? So argument of z, maximum argument of z is going to be this angle, right? This angle, which is pi minus theta, right? So pi minus theta is the maximum value. So argument of z max value is equal to pi minus theta, and that is going to be pi minus tan inverse of 3 by 4. All right. So in this way, you can write the maximum value without making extra efforts. So I hope you have got this question. Is it okay, guys? So these are some important questions based on equation of circle. Okay, equation of circle. Now I'll move to another curve. So the next curve is second one. If z1 and z2 are two fixed complex numbers and z is a variable complex number such that z minus z1 mod is equal to mod of z minus z2, then z lies on. What will be the locus? This is again very simple, very easy. Okay, so the first two curves are very basic curves, but questions are very important based on these two curves. So z1 is here and z2 is here. Now this represents distance of z from z1, and this is distance of z from z2, right? So he's saying, the equation says that distance of z from z1 is equal to distance of z from z2. So when does that happen? It's very simple. You are doing this locus from class 9th, right? Or 8th even. Distance of z from z1 is equal to distance. So a point is moving in such a way that its distance from two fixed points are equal, right? Distances are equal. So that means that point will lie on the perpendicular bisector of line joining these two fixed points, right? So it will, z will move on this line, which is perpendicular bisector of line joining z1 and z2, right? Got it? Subhashri, are you getting it? Z will lie on this. Have you got the previous question? Okay, let's shift this Z2. Seems, right? Now diagram is good, looking good. Yes, in evening also I have one class, and in that class I will be discussing continuity. Okay, continuity, like I was discussing yesterday. So locus of Z is perpendicular bisector of line joining Z1 and Z2. Okay, so that's it. Perpendicular locus of Z is line joining perpendicular bisector of line joining Z1 and Z2. Okay, so I hope this is clear. Now what will happen if I write second part of this? Same question. This is the first part. Now second part, I am putting the inequality. Okay, in place of equality I'm putting the inequality like this: Z minus Z1 is greater than Z minus Z2. So as I told you in circles also, whenever you are putting in equation inequality in place of equality, um, equal to sign, that then the new inequation represents a region. Okay, so inequation always represents a region, and which region will it be? It will be the either one side of the region represented by the equation equality. All right, so equality was representing this vertical line, right? Line joining, not vertical, sorry, line perpendicular bisector of line joining Z1 and Z2. So now this line is going to be the boundary, and you can see there will be two portions. One is right side of this according to this diagram, then other is left side of this. So two regions you can see, right side of this line or left side of this line. All right, so when Z will not lie on this line, so that means Z minus Z1 will not be equal to Z minus Z2. That means one of this term will be greater than the other term. Okay, so you can easily figure it out that in this inequation, where will this Z lies? Right side of this line or left side of this line? Okay, let's plot it again. So this is Z1 and this is Z2. This is a vertical line. So if I take Z on this line, then Z minus Z1 is equal to Z minus Z2 mod. But if I take Z right side, this side, okay, this side, so that means Z will be close to Z2, right? You can see this distance is obviously smaller than Z minus Z1 mod. Yeah, so perfect. Yes, Z satisfies. So this region will satisfy, or you can say points of this region will satisfy the given inequation. All right. And if you reverse the inequality sign, if you reverse this, then it will be the opposite region, the region of Z1 side, the side of Z1. Okay. So I hope this is clear. I'll give you one question based on this. So if Z satisfies, uh, mod of Z is equal to mod of Z is equal to maximum of not one minute mod of Z is equal to minimum of or maximum of minimum of, that would be good. Yeah, so mod of Z satisfies minimum of mod of Z minus 1 comma mod of Z plus 1. All right, then find real part of Z. It's a very good question. Try this one. Okay, so this is the last sum, and we'll continue this complex geometry tomorrow as well. Okay, so I'll take 3 sessions and complete this complex geometry, complete all the curves, parabola, ellipse, hyperbola, circle and straight line we are doing today, and arguments, rays, arcs, everything will be covered. Okay, all types of equations of circles. One more circle is remaining. So I'll finish it in 2-3 sessions. Okay, let's see. Are you doing it, Subhashri? Are you trying this sum? And are you understanding? Okay, so what is this? It's like this whenever you write minimum of a comma b. So whoever is smaller, that will be the answer. Say a is, so if a is less than b, that means this is nothing but a. All right. Like minimum of, if you write minimum of 1 comma 2, then minimum of 1 comma 2 is 1. You can write minimum of, even you can write 1 comma 2 comma 3 comma 4, as many as numbers you want, but you must know which one is the smallest among all these 4. So 1 is the smallest, so answer is 1. There's nothing but 1. So we need to compare these two values, which one is, smaller. So this represents distance. Z is a moving point, right? So this represents distance of Z from 1. So let's mark 1 somewhere, and this represents distance of Z from -1. Okay, Z -1. This is -1. So if I take a point, point on y-axis, y-axis is perpendicular bisector. You can see that, right? Y-axis is perpendicular bisector of line joining -1 and 1. So if I take Z on y-axis, then these two distances will be equal, right? So on this, Z minus 1 mod is equal to mod of Z plus 1. So you can't find minimum. So let's take Z either on right side of y-axis or left side. So let's take on right side. Okay, here. So if I take Z on the right side, okay, so I'm taking case 1. Okay, case 1, when Z, or you can write when Z lies right side, that means you can write real part of Z is positive. Real part of Z means X, right? If you write Z is equal to X plus IY, then X is positive. X is positive means Z is on the right side of y-axis. Okay, so when real part of Z is more than 0, then which will be minimum? Can you answer this? Which will be minimum? Mod of Z minus 1 or mod of Z plus 1? Clearly you can see this is smaller, right? Then minimum of mod of Z plus 1 comma mod of Z minus 1 is nothing but mod of Z minus 1. Okay, so we are taking this case. So in this case, mod of Z minus 1 is minimum, right? So now this equation will become mod of Z is equal to mod of Z minus 1. Okay, so now we have decided that which one is minimum. Okay, so we have got one term outside this expression. Now that term will be equal to mod of Z, and that is now our final equation. Okay, so we need to simplify it. Now what does this represent? This represents distance of Z from origin. This represents distance of Z from 1. So that means distance of Z from origin and distance of Z from 1, that means are equal. That means Z lies on the perpendicular bisector of these 2 points, line joining these 2 points, right? So Z will lie on this, and this line is lying in the region which we have selected. Yes, of course it is lying, right? So perfect. That means Z will be on this line. Okay, on this line. So we have got our Z, okay, in the selected region. What is this line, by the way? This line is X is equal to 1 by 2. Okay, so this means Z lies on X is equal to 1 by 2 line. So what will be the real part of Z? So real part of Z will be 1 by 2. Okay, but now we have one more case to discuss. What is case 2, by the way? Case 2 is when Z lies, when real part of Z is less than 0. That means Z lies on the left side of y-axis. Now Z is here. So if Z is here, then you can see which one will be smaller. Now which one will be smaller? This is mod of z minus 1. Now this is mod of z plus 1. So in this case, now this is the smaller value, minimum of z minus 1 mod, comma mod of z plus 1, right? So now equation will become mod of z is equal to mod of z plus 1. Now we need to solve this equation, okay? So as we have solved the previous equation, similar way we can solve this one also. So this represents distance of z from origin, and the second term right side of the equation represents distance of z from minus 1. So these two distances are equal. That means z lies on the perpendicular bisector of line joining minus 1 and 0, right? So in this case, z lies on this line. Which line? This line is x is equal to minus 1 by 2. And this line falls in the region which we have taken in case 2, real part of left side of y-axis. So yes, what is the real part in this case? So real part of z in this case will be minus 1 by 2, okay? So we are getting two answers. Either real part of z will be 1 by 2 or it will be minus 1 by 2. That is our final answer. So I hope you have got it. Let me know. Subhashri, have you got it? Understood this? Everything? Or Vamsi, is it clear? All right, Vamsi, good to go. Then in that case, we'll continue tomorrow. Okay, complex geometry will continue tomorrow. So today we have covered basic curves, but questions are very good based on these two basic curves. Lots of questions they ask from these two curves only. All right, mostly questions in JEE main and sometimes in advanced also. They use these curves. Okay, so these two basic curves are very important. So you should do it properly. Questions based on, or there are many types of questions based on these two. Okay, so we'll continue tomorrow. Till then, bye. Thank you very much for watching this video. Subscribe the channel and like my videos if you're enjoying watching them. All right, and use the code JEET1 to get 10% discount in your Plus subscription if you're planning to take it. All right, so thank you very much. All right.